Good morning, and if you have just woken up and seen... Alright, nothing but basic, that one there is what I want. I cannot tell if you guys can see what's going on with the Kicad. Just checking up on it now, and oh, that sucks. Oh, you're kidding me. You guys can just see a blank screen of Kicad. You cannot see the actual Kicad schematic. That is, oh man, that's terrible. Well, what I was going to show you is the Kicad schematic, or the creation of a Kicad schematic for a RAM, ROM, 8K RAM and 8K ROM module, but OBS Studio is really doing something to that bed. You can see the project. Where are we hiding here? I'm gonna wait till you guys catch up here. There you go. You guys can see the project. That's all you guys can see. This is yeah, crap. This is not good. This is not good. How do I fix this? I might have to come back to this one. Is there a setting in full screen, blending mode, scale filtering? I don't even know how you'd look. Okay, so display capture. Get rid of window. And then I'll be back in a couple seconds. Right, what I'm doing is just checking the video feed on another device, and that device is mobile, so bear with me for 1 second while I learn how to navigate a phone. I'm trying to get distracted. That one there. One watching, two watching. Navigate a phone. Trying to get distracted. I'm just waiting for the latency to change. If it is working, what you have in front of you is the 6502 computer that I've got. So just a quick rundown of what we've got in Kicad. There is the memory map with the addresses and some of the ideas I have for it. Good. You can see it. This is not good though, because you can see part of that behind you. Cool. Alright, what we'll do is, how do I get rid of... Okay, you guys are going to have to put up with that crap behind you. And I'll try not to drop the mic this time. Alright. trying to find a page. Yeah, so what you should be seeing up on the top right here is that's distracting. Just turn that off. It's just, we should be seeing as the Kicad icons on the side, but it's not, so we'll just not worry about it. It may be an incompatibility between the OBS and Kicad. But let's get back to this. The most important part's our ROM. That's where ROM is being loaded in on the memory. Our RAM starts at 00, and what we're planning to do is have our, where the ACI for the Apple II was, which doesn't work on my 6502 for different reasons. We'll put the ROM basic there. Let's just edit this. So we'll put RAM part 2. Okay, we'll get rid of the graphics. Don't worry, I have already saved. Did a little bit of setup. Nothing there. Spare. Nothing there. These are all 8251. We need that. These are all mapped out with a address mapper and ROM. So we'll put basic there. Because the ROM, that ROM will also do, call it. Okay, so monitor / BIOS ROM and RAM module 2. So this is what we'll be working on this today. Save that there, that. So module mod ULE. Okay, so let's just do a quick tour of the 6502 that I have. This is the working one. So your processor, we have, of course, the address and data bus. We do have the read-write signal across. You can use the IRQ and the ready one. I'm not using the non-maskable interrupt. We could use that on a different board. Sync's not connected. Okay, this isn't the right one. Yes, it is the right one. Sync's not being used, and the I can't remember what that one is. I think it shows where the processor is in its cycle. Next bit is our RAM. So this is from 2 to 3 FF. So actually we'll get rid of, because we're not using it, we can get rid of the RAM. The processor. That's the LED, we're not using that one there. So that gives us our RAM. There's also a ROM here too. And that's our ROM. If we can get it to say move across nicely. Cool, we can. Oh, come on, Kicad, stop. Kicad has these little quirks that you've got to get used to. Alright, so there, it's just the chip, read write. I'll leave that for now because that's just read write decoding. Put that up there. So this is the RAM decoding, so it's very basic, and as you can see, you've got a lot of unused real estate for memory, especially when you're using the serial port and the user port, and the graphics and the ACI, well, not graphics and ACI. So those 3 ports, and that's a little big waste of space. The next version one, I've got a different method of peripherals, but we're just concentrating on the version 1.1 at the moment. I'll get rid of that because we're not needing it. That's just power and decoupling, and this is the reset circuit, which we don't need. Just a quick one about this reset circuit is that for the 6502, the older versions, there was an error or issue with the reset. If you held it in reset too long, you fried the chip, and I've learned the hard way that you can fry the chip. User port 1, so that's based off the BBC Micro, and that just goes to the 6522 there, which we're not using, so we can get rid of that. Expansion ports, this is what we'll keep because we're using that. It's the 6502, we don't really need to know much about that one. This is for the serial port, various baud rates, and this here is actually in an error as I'm using the 2.4576 megahertz crystal, and it's at 16 times on the clock. We'll get rid of that there. We don't need that. And the 8251, which is an Intel serial port. It has a logic high reset, so we have to invert the reset on the logic low side for the 6502. And you got serial coming out, and you return ready to send, clear to send signals, and they are not being used in hardware, and so it's all controlled via software, and it's just an old feature. We could just bridge them if we want to. The same with the DTR, DSR. It's either done in software or hardware, and I've just bridged it to be safe. Yeah, we don't need that. Okay, so what does that leave us with? 2 devices, and your ROM, and your RAM, the inversion for the read-write signal, and our power as well. Okay, this is actually quicker than I thought it was going to be. And our data bus. We don't need that many caps. 1 and 2, 3. If I leave that, no, I'm going to keep that. Okay, I'll keep that there because I need that read-write for the inversion for the chip, for the RAM. Right, RAM enabled and ROM enabled. So we do that one and that one, and the ROM is going to be at C00. And the RAM is at that point there, so from 2 to 4. Drop the mic again. Okay, so RAM from 2 to 4, so we do a copy and rotate it. Put it there. So, does everything look tickety-boo? It should be, because it's just a complete copy of the what is it? Processor 1. Just a little bit of tidy up of the stuff we're not using. We're using the clock. Should we be using the clock? No, we're not using the clock. We're not using the resets. Read write we're definitely using. Those ones we're definitely using. So Mac is unused. And that looks like it's good. Let's see, we've only got 1, 2, 3. and that just leaves us with 5V ground, big cap on the input, 1, 2, 3 chips for the RAM ROM. Oh, that's right, this is what I was going to do as well. Now we could use this as is. My concern is I'm overloading the bus I already have there because I do not have any buffering. So what we can do for buffering is, this should be very easy to implement on the buffering side. I could still use that as a monitoring. 1 second. Cool. I don't know if you can see what I'm pulling up here, but 74 alias 573. So the 573 are the same as a 373, except that you've got 2, 3, 4. On the left hand side, you get your data coming in. On the right hand side, you get your data going out. Okay, you can see that. We need 2 of those. So that's the buffering. And we're going to cheat. We can cheat here, so we can label that. -1 and -1. This way we can do. That works. Control copy. Control V. Get rid of that one there. Oops. We don't want to control copy it, we just want to move it down. Right, so that just goes there. That goes there. That goes there. And we just do this because I just made a mistake. Simple. Mistake fixed. And it means I've also got to add more caps in here. And seeing I've already had got the caps. Seeing I've already have the footprint for the caps, it's just as simple as adding them in. And it's the same for the connector and those other ICs. These 573s are 20-pin devices, so we should be able to do those quite easily. Let's see here, and we might have to move that across one. Okay, so the data bus. No, that's not what I wanted. I wanted the address bus. Okay, so we do that again. So that's the output for the address bus. Control copy, Control V. And there we go. -1. Alright, so input from the address bus out to the data bus. Now, when do we want to load it? It's a good question. That would be that clock we just got rid of. We could load it on the clock, or we could have it always being loaded. What we'll do is we'll just have it always loaded. So wire. It loads positive. Interesting. Object enable. Unless I've got the wrong one, but we'll worry about that later. Copy. Okay, so 1, 2, 3, 4, 5. Okay. So the octal bus transceiver. Which one is it? I think it's this one here. And chip enable. We'll grab some data buses, which is the easiest one to grab. That one there. Copy. So that is that one, and Control V. -1. Right, so that leaves. I really do need a different mic. You guys probably didn't hear that I just dropped it again. And the audio quality is probably not that great. It is just a headphone mic, and that's all it is. Alright, so I'm going to just quickly check the data sheet for. Can we easily get? How do we get the data sheet? Oh, there we go. Cool, that was nice. Alright, the data sheet means that if we are going from, we'll do the footprint now. Data sheet, how many pins is it? It's a 20 pin device. Okay, so waiting on Kicad. Don't crash Kicad. Okay, Kicad. I said don't crash. There we go. Package dip. Package dip. Looks like you guys can't see that the PDF. That's not good. That's terrible. Alright, so hopefully you can see what I'm doing here with the dip package. So I'm looking for a dip 27.2, that one there, and we just could use the circular long pads. I like the long pads, especially if I'm doing my own board. And right, now we're going to check to see if the read write pin is correct. You guys can't see this, so let's see. So low equals B to A, so that is a read from B to A, which means if we're reading from our RAM, let's go from B to A, and if we're writing from our RAM, let's go from the other way. Okay, cool. Or the ROM as well. So we're good to go there. Sorry you guys can't see the PDF. It looks terrible. Ha, you guys can't even see the pin selection I did too. Screen capturing is pretty crap for what I'm doing. It's on an old laptop. Let's just say it's about 10 years old. Alright, so we have, yep, back to the schematic. I can see it now. Let's see. So that should be good to go. So we will do our design rules check, run. See, capacitor's not annotated. So 1, 2, 3. 6. Save it, and then we've got a pack pin footprint. These are all 20 pins anyway, so we can do, save you a little bit of not being able to see what I'm doing. And that should be right. And DRC 6. It's not connected to any other signal. Right. So we're not using that ready pin, and the not wire. Right. Ooh, we're not connected. Yeah, right. So this one here. So that one there gives us our read write, and we should be good to go now. There we go. Alright, let's draw this out and update from PCB. Alright, so this is our schematic, PCB, the design of move. What happens if I do it? Okay, this is now very slow. Alright, I like that pin out, but bear with me while it crashes. Okay, so 3D settings is not what I wanted. Let's change the footprint on that. just changing the footprint to a vertical header because I'm not actually plugging it directly into the PCB. Okay, alright. So 3, 4. Moving everything into a rough location of where I want it. Okay, so C1 will go with C1 will go with U1. If we move U1 down 1 line. And C6. All right. It's quite a small board. How big could that be? Dimension. So from there to, actually I'm going to move this one here. Alright. Oh, the cap. Where's that going? It's going over. It should be as close as possible. And no, I hate it when it does that. Right, so a big decoupling cap there. Let's move it further forward. Okay. This time let's do some measurements. So, or do we just do the, we'll do the cutout first, margin. What I'd noticed was that was printed around the wrong way, so what we've just done is reprinted it to be around the right way. And how big is this? It is, we don't want to do that, we want that one there. It is exactly 113 by 72. So it's 113 by 72 mil. So it's not too small, it's not too big. It's about the right size. This is the next fun bit. It's actually going to turn you off because you don't want to watch this. It's going to take forever. Unless you want to watch me struggle with getting this done. Alright, I'm going to turn this off and I'll see you guys later.